Okay, so the topic one, it's about fundamentals of cryptography, fundamentals of cryptography. So topic one, lecture one, we are looking at the module overview and the overview of security, the module overview and the overview of security. So this topic will cover introduction to the module, overview of security, overview of cryptography, block ciphers, public key ciphers, hash algorithms. And by the end of this topic, you'll be able to explain the most common types of cryptographic algorithms, that is block ciphers, public keys, and hash algorithms. Select and justify any appropriate algorithm for a particular purpose. So the aim of this course is to provide you with underlying theory and practical skills required to secure a network, and to send data safely and securely over network communication, including securing the most common internet services, So the syllabus, the module syllabus, it has the cryptography fundamentals, public key infrastructure. This is where we have the encryption. Then we have web security, the email security, the data protection, vulnerability assessment, as well as authentication. Access control, files, the VPNs, remote access, then the wireless security. Module delivery, of course, a lecturer or a teacher will lead time for this module, which is comprised of lectures and laboratory sessions. There's a practical part and the theory part. Then assignment is more like the practical, because you'll be designing a network, be configuring networks, implementing the security features and so on. So you'll be encouraged to be active during lectures by raising questions, so you can ask questions and taking part in discussions. So laboratory sessions are designed to follow the respective topic as well as lectures. During these sessions, you'll be required to work through practical tutorials and various exercises. Private study is very important. Let's say after class, you can be studying, taking exercise, coming up with solutions. You already have the assignment, so no problem. The assessment is 50-50. Remember, 50-50. There's 50% exam and 50% coursework. So let's look at computer security. What is the computer security? There is a definition of a computer security. Computer security is a protection. The protection afforded to an automated information systems in order to attain the applicable objectives of preserving the integrity, availability, confidentiality of information system resources, including hardware, software, and firmware, information/data and telecommunication. So CIA TRAND is being applied there. CIA TRAND. That's why we have integrity, availability, and the confidentiality, isn't it? Information system, in order to attain the applicable objective of preserving the integrity, availability, and confidentiality. If there's no protection, there is no way you can preserve these three: availability, confidentiality, and resources. Let's say if the network is under attack, the information is not going to be available. The hackers are going to take charge. The hackers are going to withhold the information that will make it unavailable to the people who are supposed to use the information, isn't it? It won't be available. You can't access it. Then confidentiality. What do you understand by the word confidentiality? Confidentiality. Yeah, private, right? Information within the organization is not supposed to be found outside or to your competitors or whatsoever. Even within the organization, these employees, they are not on the same level, isn't it? They're not on the same level. We have those, let's say, the top managers, like they on the strategic level. There is information that they know that they can't share it to the middle level, isn't it? So information is supposed to be is not supposed to be given to someone who is not supposed to. Then we talked about the integrity. What about the integrity? What do you understand by the word integrity? So after this class, you should go and research on CIA trend. Research on CIA trend, as in TRIAND, CIA trend. Or we can say CIA triangle, it's the same, CIA triangle, research on it. So you should study on availability, what is availability, what is it up to, what is integrity, as well as the confidentiality, Okay, so that is the definition of computer security, the protection afforded to an automated information system. Automated information system, not manual, only automated. And cryptography, the definition of cryptography, the discipline that embodies the principles, means, and methods for the transformation of data in order to hide their semantic content, prevent their unauthorized use of, or prevent their undetected modification. So the discipline that embodies the principles, means, and methods for transformation of data in order to hide their semantic content. Actually, we're talking about encryption. We're talking about encryption. It's about hiding the information, hiding the content so that it is not seen to someone who is not intended, okay? By providing the keys, private keys, public keys, protecting them, scrambling the messages so that it is secured. Unless if you are intended, then you are going to have, if you are a recipient, you are going to have a key. If you are a recipient, you are going to have a key. That is a cryptography. Then security objectives. What is an objective? The word objective. What do you understand by the word objective? Objective, something to be achieved, isn't it? Something that you need to achieve is an objective. So in security, there are objectives, there are things that need to be achieved. One, confidentiality needs to be achieved. Preserving authorized restriction on information, access, and disclosure, including means for protecting personal privacy and proprietary information. Confidentiality. Then integrity is about guarding against improper information modification or destruction, including ensuring information non-repudiation and authenticity. What does a non-repudiation means? It means that you should acknowledge certain things, of doing certain things. Let's say you are accessing the system today and something go wrong, and they say, who was logged in when this happens? Then you refuse. But with the non-repudiation, you are not able to refuse because the system is able to keep the logs and say, Esther logged in at this and this, at this at a time, isn't it? Even in banks, it happens. The reason why the cameras, the CCTV cameras are put on ATMs is for a reason, to avoid a non-repudiation, whereby you do certain things and then you come and refuse that I'm not the one, I'm not responsible for this. Like you go and withdraw money and you go to the bank and say, I've lost so much. I didn't withdraw the money. Then the bank will say, no, you came. Here is the footage. You came at this time. You withdraw so much. You're not able to refuse. Here is a receipt. You are also given a receipt. So those should be put in place to make sure that people should learn to acknowledge the mistakes, isn't it? Then we have availability, ensuring timely and reliable access and use of information. Availability, meaning that information should be available at any time. Whenever we need it, information should always be there. Loss of security. The following defines the loss of security in each objective. Loss of confidentiality. If you have lost confidence in certain things, meaning that why do we lose confidentiality? Meaning that unauthorized disclosure of information. There is unauthorized disclosure of information. Loss of integrity, unauthorized modification or destruction of information. Loss of availability, disruption of access to or use information or information systems. That's the loss of security. The CIA trend. I've already talked about the CIA trend. So this is just going through the things we have already talked about. The CIA trend, these requirements, which is confidentiality, integrity, and availability, are common known as CIA trend. There are many critics that suggest that this does not provide a complete picture of security requirements. The two most common cited extra requirements are authenticity, accountability. These are the two most commonly cited extra requirements, authenticity and accountability. Let's talk about the authenticity. Authenticity is about being genuine, verified, and trusted, the authenticity. What's the authenticity of this information? Okay. Confidence in the validity of a transmission, a message, and the message originator. Confidence. Then verifying that the users are who they say they are, and that each message comes from a trusted source. In networking, all these should be there in terms of security. In terms of security, you have to verify that the users are who they claim to be. No wonder when you want to open your email address, you are going to enter the password, isn't it? So that the server can synchronize what you have entered and what the server is already, the system is already keeping. Just to make sure that you are the person who claim, you are the person claimed to be who you are. Then accountability. Actions of an entity can be traced uniquely to that entity. Supports non-repudiation. I've talked about non-repudiation. Deterrence, fault isolation, intrusion detection and prevention. Intrusion detection, like detecting the intrusions. If there are some people logged in, or if there are some errors, or if there are some hackers, or if there's some malwares, you're trying to detect the intruder. Is there any intruder in the system? So you can detect that. You can configure the IDS, intrusion detection system, in file, or including in the routers, or on its own. Then recovery and the legal action. So these are money support. Then OIS security architects, Open System Interconnection Security Architects, ITU-T recommendation, X800 security. Architecture for OSI provide a systematic way for defining the requirements for security, characterizing the approach to satisfying those requirements. ITU-T standards for international telecommunications and union telecommunication standardizations sector. OI stands for Open System Interconnections. Open System Interconnections. OI security architecture, the following concepts are used. We have security attack, any actions that compromise the security of information owned by an organization or a person. Any actions that compromise the security of information owned by an organization or an individual. Then security mechanism, a mechanism that is designed to detect, prevent, or recover from a security attack. A mechanism that is designed to detect, prevent, or recover from a security attack. Security service, a service that enhances the security of the data process system and the information transfer of an organization. The services make use of one or more security mechanisms to provide the service. Security attack, it is useful to categorize attacks as passive and active. There's a passive attack and active attack. Passive attacks make use of information from a system, but do not affect the system resources. Those are just passive. Then the active attacks, they alter system resources or affect their operations, Passive attacks, a release of messages contents, the information in a message is read. Then traffic analysis, message information cannot be read, but traffic patterns are analyzed to glean information. Then we have active attacks. One, masquerading. What do you understand by the word masquerading? Or have you heard this word called masquerade? Or when they say masquerading to be someone else, this person is masquerading to be a medical doctor. Means that someone is pretending to be who they are not, isn't it? Masquerading. So it's very common in network attacks. One entity pretends to be another entity. That's masquerading. Me, I pretend to be you. Right? That's masquerading. Then replay. Passive capture of data and its retransmission to produce an authorized effect. Passive capture of data and its retransmission to produce an authorized effect. Like you replay, you redo something that has been done in order to retransmit the information. In short, replay is to actually retransmit to produce an authorized effect. Then message modifications, a message is altered to produce an authorized effect where the message is being changed. The message is being changed by a third party who happens to be the hacker. Then denial of service. Denial of service attack, actually, we call it a DOS, denial of service attack. This is where hacker denies entry. Hackers denies entry. Not hackers denied. Hackers will deny the legitimate user entry to the system. You are the legitimate user, but you are failing to log in, meaning that without you knowing that the hackers actually have invaded the system and they have denied you entry. So you just thinking that it's normal, my computer is frozen, my computer is acting up, not knowing that the hackers are in the system, they are busy sending the messages. By the time you are realizing, as a legitimate user, the important data is gone. Denial of service, preventing or hindering the use of network resources. We call it denial of service attack. It's an attack. Then security services. A security service is a service which ensures adequate security of the system or of data transfer. X800 recommendation divides security services into 5 categories. There is authentication, access control, data confidentiality, data integrity, and non-repudiation. Then security mechanisms. Security mechanisms are used to implement security services. They include encipherment, digital signature, access control mechanisms, data integrity mechanisms, authentication exchange, traffic padding, routing control, and notarization. Number of theories. Main public key crypto system use non-trivial number theory. Non-trivial number theory. The RSA public key crypto system is based on the difficulty of factory large number. We will outline the basic ideas of divisors, prime numbers, and the modular arithmetic. Divisors and prime numbers, let A and B be integers where B is not equal to 0. Then we say B is a divisor of A if there is an integer M such that A is equal to MB. So that's that A is equal to MB. Those are divisors. Then prime numbers, an integer P is a prime number. If its only divisors are 1, -1, P, then negative P. Then GCD and relative prime numbers, greatest common divisors. GCD in brackets AB is a greatest common divisor of A and B. The largest number that divides into both numbers. Examples, GCD, we're going to have 12 and 15. How many 3s can go into 12? With a remainder or without a remainder?
Without remainder.
Sorry?
Without the remainder.
Without the remainder? Okay, so it's a divisor. What about 15? Can a 3 go without a remainder? In 15? Yes. So it's a divisor. Mm-hmm. Then GCD, also 49 and 14. We can use 7 as a divisor because 7 can go into 14 without a remainder and 7 can go into 49 without a remainder, isn't it? What else can we pick? We can pick something. 10 in 20, isn't it? And 50 can go without a remainder, isn't it? So we can go on and on. Then relative prime numbers, let's call it prime numbers. A and B are relative prime if GCD AB is equal to 1. Example, GCD 9 and 14. 1 can go into 9. And 1 can go into 14 without remainders. Those are prime numbers. Then modular arithmetic, if A is an integer and N is a positive integer, we define A mod N to be the remainder when A is divided by N. N is just a number. Example, 10 mod 3 is equal to 1. Mod 3 is equal to 1. So if A, open bracket, if A mod N is equal to B mod N, then A, B are congruent modular N. A modular N is equal to B mod N if N is a divisor of AB, a divisor of AB. Okay. We continue. Let's look at the cryptography now in detail. A cryptography is a collection of mathematical techniques for protecting information. Most important techniques in encryption and decryption. That is a definition of cryptography. If they say, what's a cryptography? I can say a cryptography is a collection of mathematical techniques for protecting information. Most important techniques, we have encryption and decryption. We have symmetric encryption, symmetric key encryption, encrypt and decrypt message using the same key. Remember I said using there's just one key. For encrypting and for decrypting is one key. That is for symmetric. Then we have asymmetric that uses two keys. Asymmetric encryption, key encryption. One key used for encryption, which is a public key. Another key used for decryption, which is a public key, So that is a symmetric key encryption, symmetric encryption. So we have a plain text, as you can see. So look where we have a plain text. We have two plain texts on the senders and on the receivers, right? Input and output. So in input, in between we have a lock, meaning that a plain text, when it's in transmission, it is encrypted, right? Then it will be transmitted after encryption. Transmitted. Then when it reaches the recipient on the other side, it has to be decrypted. So the receiver needs to decrypt it. The receiver at this point should have a secret key. If they don't have a key, they're not going to decrypt this message. It will remain unread, unopened. You can't open it. It's like you can't open the gate after locking because you don't have a key. So we have secret key shared by sender and recipient. Then on the other side, secret key shared by sender and the recipient, it should be used to unlock it. So elements of symmetric encryption, elements of symmetric encryption. Elements, when I say elements, we have plain text, encryption algorithm, secret key, ciphertext, and the decryption algorithms. Those are the elements of symmetric encryption elements. Don't forget plain text, encryption algorithm, secret key, ciphertext, or decryption algorithms. Ciphertext is encrypted text. The other name for ciphertext is encrypted. The other name for deciphered is an encrypted text. So we have cipher, deciphered, encrypted, decrypted, the same thing. Principles of symmetric encryption, security of symmetric encryption depends on the secrecy of the key. It does not depend on the secrecy of the algorithms. Why? It is difficult to invent new algorithms and keep them secret. It is relatively simple to produce keys. Relatively simple to produce keys. Requirements for symmetric encryption, we have strong encryption. Under strong encryption, the attacker should be unable to decrypt encrypted text, even if he or she knows several matching pairs of the plain text. No wonder they say even when you are setting up a password, don't use if it's text, you use text all the way. If it's numbers, use text all the numbers. If it's you have to mix numbers, letters, and symbols. You come up with a very strong password, isn't it?
Mm-hmm.
But if you use a password, let's say letters, people can even guess. It's very easy to crack the password. You just give me maybe 5-10 minutes. I'll try by all means to crack the password and enter into the system. So strong encryption, then the private key must be kept secret. Sender and the receiver must have obtained copies of all the secret key in a secure way and must keep the key secured. No, these hackers are not, they're not intelligent. They just collect pieces of information, not until they put everything together and then they attack. Some people, they don't even know they're seated to say. They're saying, my password is what and what and what and what. They share the password and it's on their phone, which is not even protected. Or the person you are sitting next to, they have heard. Even in the house, I've left the keys there under the what. You don't even know the person you are seated with. They say, these people are not around. They have left the keys somewhere. You just find that they have stolen. So even thieves, they start planning way back. Maybe it's even the people you know. It's even the people maybe who have been to your place. It's the people you interact with. They have been collecting information. They have been collecting pieces of information, pieces of data. Then after they have gathered enough, they are going to put it together. And then they attack. That's how even hackers works. Okay. Classifying crypto systems, as well as classifying as symmetric or asymmetric, there are two other main classification types of operation used. There is substitutions and transpositions. The way in which plain text is processed, block cipher, where a block of elements is transformed to the output block in one go. Stream cipher, where the input elements are processed continuously, one element at a time. substitutes each element of the plain text where bit, letter, group of bits is mapped into another element. Let's say A, we have these examples, A, arrow, B, meaning that A is pointing to B. Hello, minister, the substitute. Then BC becomes IFM, and JUFS. We are just trying to come up with something we can use to secure the system, where we can use the system that can become very, very, very secured. So the password can start from Z to A, or A, maybe B, or B to C, just like that. Transpositions, elements of the plain text are rearranged. Instead of writing hello, you start with HEL, then LOMIS, then TER, which will become like that, as you can see. HLM. Okay, in short, HLMTEOIELSR, they are coming from the word hello, Mr., isn't it? The password is created. It just up to you to put letters together. Okay. If you put the password hello, minister, it will be very easy for someone to crack it, right? But from the word, from your name, actually, your first name and the last name, and the middle name as well, you can come up with a strong password that people can't put these letters together, isn't it? Yes. At the end of the day, don't just make the password straightforward. Then real-world encryption, modern algorithms have multiple stages in converting the plain text to ciphertext. They usually involve multiple substitutions and transpositions. The encryption uses a key, unlike the simple examples on the previous slides. Crypto analysis. The main objective of an attack is to recover the key rather than a plain text. They just want a key so that they can decrypt. Relies on knowledge of the nature of the algorithm plus knowledge of the plain text or access to some plain text ciphertext pairs. An encryption scheme is computationally secure if the cost of breaking the scheme exceeds the value of the encrypted information. What we are saying, as a hacker, the information is being encrypted. And by decrypting it, you need money to buy the resources. But if you can spend more just to encrypt a simple document, you spend a lot of money. So you'll find that the cost of buying the technology that you want, it will cost more than the things that the document that you are going to get from the back doors. It won't give you so much. So if the costs outweigh the profit, I don't know if the profit you are going to get, you find that it's not worth decrypting it, isn't it? It's about, we're talking about protecting something. Someone has got a can temper, and in that shop, there's just sweet and the toothbrush and salt. And they want to protect it buying CCTV cameras that will cost them millions of dollars and other equipment. And yet what they're protecting is not even worth it. Maybe it doesn't even, it won't even cost 500 kwacha. Do you think it is worth buying such equipment? It's not, right? So we have to gauge, what are we trying to protect? What are we trying to protect? How much am I going to spend? If we talk of ShopRite, you can invest. A shop like ShopRite, you can invest. CCTV cameras and other security measures, isn't it? Because there's a lot that you are protecting, worth billions of money, isn't it? So encryption scheme is computationally secure if the cost of breaking the scheme exceeds the value. Okay. The time required to break to the scheme is more than lifetime of the information. There is also a brute force. That's another type, brute force attack. Try every possible key until correct translation of the encrypted text into plain text is obtained. The problem is the time required to do this. On average, an attacker must try half of all possible keys before successfully translating a ciphertext for a key size of 32 bits. There are 232, which is 4.3 by 109 alternative keys. At 1 decryption per microsecond, 35.8 minutes. At 1 million description per microsecond, which is 2.15 milliseconds, a brute force. A brute force attack increasing key size. For a key size of 56 bit, there are 256, which is 7.2 by 1016 alternative keys. 1 description per microsecond, which is 1142 years. At 1 million description per microsecond, for a key size of 128 bits, there are 2,128, which is 3.4 by 1,008 alternative keys. So there are a lot of keys in 128 bits. You can come up with a lot of keys, not just one key, but many different types of keys. So decryption per microsecond, which is 5.4 by 1,024 years, a lot of years. At 1 million decryption per microsecond, 5.9 by 1,030 years. Then we have block cipher versus stream cipher. Block ciphers use algorithms to encrypt and decrypt a fixed size block of plain text and ciphertext, respectively, usually a multiple of 64 bits. Stream ciphers continuously encrypt any amount of data as it is presented, usually by mathematically combining the data with key stream, an infinitely long key sequence that is generated based on the finite key starting value. Then we have Fiesto cipher, Fiesto cipher, a scheme used by almost all modern block ciphers, today's ciphers. The input is broken into two equal-sized blocks, generally called left and right, which are then repeatedly cycled through the algorithms. At each cycle, a function f is applied to the right block, and the key and the result of exclusive read into the left block, the block are then swapped. The exclusive read result becomes the new right block, and the altered right block becomes the left block. The process is then repeated a number of times, not until you have achieved what you want. So that's a diagram of a Fiesto cipher. We have a plain text, as you can see, a plain text which is not yet encrypted. Then on the other side, we've got a decrypted, a text is being, we have a plain text, then ciphertext, then the plain text. Plain text, cipher meaning encrypted. Encrypted meaning the plain text. DES, data encryption standard. I don't know, you go and read when it started in 1977. It uses a 6-bit key, which is sometimes stored with additional parity bits, extending its length to 64 bits. DES is a block cipher and encrypts 64-bit data blocks. It is now considered insecure. It was considered insecure in 1998 because because crackers could crack the key in 3 days. The crackers, if they mean business, they can crack the key in 3 days. Today they try, tomorrow they try, the other day they can crack it. Then advanced, we have advanced, which is advanced is better than the data description standard. Advanced encryption standard is more secured than DES. So AES replaces DES, a fast block cipher with variable key length and block sizes. Each can be independently set to 128 or 192 or 256 bits. An official use government standard since 2002, now widely used for commercial and private encryption processes. The algorithm is public and its use is unrestricted with no royalties or license fee owed to the inventor. What I'll do, we are going to do this practically. We have to know how to cipher the text using advanced encryption or using data encryption. Then this one, designers use a theory of finite fields, a branch of algebra. Every block of 128 bits is presented by 4 by 4 array of bits. Every round except start and end has 4 steps: substitution, shift rows, mix columns, and round key. So the algorithm will have key expansion and initial round. Key expansion round keys are derived from the cipher key. Initial round, add round key. Each byte of the state is combined with the round key using a bitwise. Then round sub bytes, a non-linear substitute step which each byte is replaced with another according to a lookup table. Shift row, a transposition step where each row of the state is shifted cyclically a certain number of steps. Mix columns, a mixed column operation which operates on the columns of the state, combining the 4 bytes in each column. Then add round key. Then final round, no mixed columns, sub bytes, shift rows, and add round key. So this is the example of AES sub bytes. Each byte is replaced with another based on a lookup table. So as you can see, A2, comma 2 is replaced by B2, comma 2. You just swap them, sub bytes. We are going to do this practically. I think in the next class, we are going to use this type of ciphering and deciphering. So all these, they need our practicals. Okay. Then public key, it's the same thing. Public key, we've already gone through this. Any questions? Okay.